everybody, Amy here. So what I'm going to do today is basically reshoot our ProveIt session. Two reasons for that. First, our session had a big announcement that I want to start talking about now, and I don't want to wait a month for the official video to get posted. And second, my demo actually ran fast, so I ended up skipping some stuff I wanted to share. So I promise today you are going to see the exact same software. It's going to be the exact same script. But honestly, it's just a little more polished because I find it way easier to talk to a camera alone in my living room instead of in front of a crowd at the expo hall. All right, so here we go. ProveIt 2026 Skellig session take 2. Hey everybody, my name is Amy Williams and I'm an engineer at Skellig. Now we are a systems integrator and digital transformation consultant that works exclusively in the life science industry. And our mission is to use technology to transform our industry to make healthcare more accessible. Now, before we dive in, I need to give you a little bit of context. This ProveIt session might seem a little bit different than some of the others, and that's because Skellig had an opportunity this year to actually help with the conference in that we actually designed the data set for Enterprise C. Speaking of, let me explain Enterprise C a little bit. It is a biotech process aptly named Point 3 Therapeutics, or PTT for short. It uses batch processing. It has 4 pieces of OEM single-use equipment. And if we look at the UNS, each piece of equipment is publishing its raw namespace. And let me show you that really quick. All right. So as you can see here, we have some data for the sub. Looks like it's currently getting prompted to start the transfer into feed 2, whatever feed 2 is. If we scroll down, we would see the other pieces of equipment. And really quick, here's TFF. Now, one thing you might notice is all of these tags aren't particularly helpful. They are basically verbatim whatever the tag was called in the PLC. Nothing is modeled, and it's not very intuitive. DP17M, not very clear what that means. Now, the good news is there is additional context to figure out what the heck these tags actually are, and that was provided via paper documents like paper batch records and paper PNIDs. But like I said, we created all of those documents and those batches. So you can kind of say when it comes to this site, we know where all the bodies are buried because we buried them. So for that reason, we didn't feel it was fair to solve a specific Enterprise C use case because we knew the answers to every problem in advance. So instead, we wanted to tackle a bigger problem. One that, yes, applies to our theoretical Enterprise C, but also the entire life science industry. And that is, companies keep buying technology instead of investing in digital transformation. Now, listen, I understand the irony in making that claim whilst being at ProveIt. Initially, I shot this video literally in the expo hall at ProveIt, where vendors all around me were showcasing how their technology solved problems. And yes, no one can deny that we have seen some incredible presentations that week where technology definitely did add value. But technology is only half the problem, especially in life sciences. Like in the year 2026, I know some of you are still using paper batch records and Excel spreadsheets to move data around, when obviously we all know that's not ideal from a tech standpoint, that's not ideal from a data standpoint. But over and over again, I see our industry struggling to fix these problems. And so the root cause is not technology, it's people, it's organizational, it's cultural, and digital strategy misalignment. So during this ProveIt session, I'm going to attempt to show how Enterprise C can start to address both of these problems, the tech one and the human one. So let's get started with first the technology one. when we talk about digital transformation, we always know the steps are connect, collect, store, analyze, visualize, find problems, report problems, solve, and repeat, right? But for today, we're only going to focus on that first step, connect and collect. Now, technically speaking, PTT is connected because they do have a broker with their data in it, but that data is a mess. So the first step, of course, is we have to model it. And since we're starting on the plant floor, we thought a great first step would be to use Ignition and build them a SCADA system. And of course, since we're at ProveIt, we gotta have AI help us out. Now, remember how I said PTT had some PNID diagrams? Let's take a look at them. All right, so here they are. We have 4 diagrams for the 4 pieces of equipment. And if we zoom in, one thing I want to point out is that they are completely flat, right? So if I try to search for the number 250, nothing comes up. The reason I did that is because I myself have suffered where, for whatever reason, I was given flat PNID diagrams and had to struggle through manually combing them to find tags. And I just thought, hey, that'll be fun. Let's make that little trick in there for the vendors to deal with. So what we decided to do is, okay, we're going to build a tool that's basically trained on PTT's shapes, and it instantiates for you some Ignition views, pipes, and UDTs. And I guess before I run the tool, I want to show you our project. We did start with this base project here. So this is linked to our tags. If we refresh, we see there's nothing there, and we have nothing on the screen. So to use the tool, all we have to do is go to the URL, and then we're just going to drag and drop our documents in there. And then we hit play. Now, this is going to take a while to run. And so while it's running, I do want to show how we used to do Ignition projects pre-agentic AI. And the first step is to open the designer. That's basically a UI for how humans can build Ignition projects. Let me log in. And so, of course, the first thing to note is it does take about, a minute to open up the designer. And so what I'm doing right now is I'm basically opening a copy of the project that is hosted in the cloud. All right, it opened. Cool. So for those maybe new to Ignition, this is the designer. This is basically how, again, humans can build out these Ignition projects. And I do want to make sure we're crystal clear on what I'm trying to showcase today, which is purely instantiation. This project already has a bunch of base symbols in it. So we basically already have the little pictures for that's a valve and that's a pump. And we already have our UDT definitions defined. All we're trying to showcase is the instantiation part. The other thing that we have set up as well is MQTT Engine. So that's a module you can buy for Ignition. And what's really cool is the engine module lets you connect your Ignition gateway to an MQTT broker, and it'll look at it, and it'll take those MQTT messages and turn them into Ignition tags for you. That's very helpful because then you can point to those tags if you want to read any data. And I'll show you that really quick. We can come on over here to MQTT Engine. If I expand this out into Enterprise C, we're actually able to see all the exact same data that we were just looking at through MQTT Explorer. And like I said, we are going to want to reference this data when we build out our instances. So what I'm going to do right now is just copy some of those tag paths into a notepad. All right. So one of the first steps when you are building an Ignition SCADA system is, of course, to make a UDT instance. And that's basically just an instance of your data model. And what I love about UDTs is right there at the edge, we can abstract away confusing PLC tags into useful data models. We can make different things now look alike. So to start, what I'm going to do is make a valve. So the way we do that, we click the plus, we say new data type instance, and then I'm going to grab my flow control valve that has two IOs, an analog input and analog output. The first thing is to try and come up with a name for it. So let's just call this maybe my oxygen control valve. Now next, we're going to come down to the IO, and I'm going to point it to that MQTT data coming from the engine. So I'm going to change my tag to a reference type, and I'm just going to paste in that tag path. I'm going to do that. So we just did that for PV, so we're going to do the same thing now for a set point. Going to make it a reference tag, set point, and hit apply. Awesome. So right now, what we've done is we've taken two of those points with kind of confusing names, FIC 25001, whatever that means, right? And we've instantiated them into our UDT model where we can now see, okay, great. My PV is clearly the valve position PV, and my set point is clearly the valve position set point, and this all has to do with my oxygen control valve. All right, so the next step now is to make our visualization. And so for that, we're going to use something in Ignition called perspective. Perspective is basically how you can build views that get displayed on web browsers. So that's really great because that means you can build stuff for a variety of hardware and even like tablets and phones. So the first step is to make something called a view. So we'll come up here, we'll right click new view, and I'll just call it ProveIt demo. Now, like I said, we already had a library made of like basic shapes, like, oh, this is a valve, this is a pump. So what we're going to do now is instantiate one of those templates with something called an embedded view. And now we just have to point our embedded view to an instance. So I'm going to grab a valve. Ooh. Now, I don't know about you, but that looks pretty bad, right? The reason that this is all red and erroring is this template is expecting to have data being passed into it, right? It's trying to display PVs and set points and tag names, but right now it's not linked to anything. So we need to link this to data from our UDT instance. And the way people traditionally do that is through passing in parameters. So to pass in a parameter, you can come over here and click the plus button, parameters, and then click one and pass in something. Now, what's funny is actually at ProveIt, I was doing this on the TV and it was bigger. There is a feature at the bottom where you can say like sync params, it'll automatically like instantiate all these for you. But I guess I have so many on this monitor at the resolution I'm at, I can't even do that. So that just goes to show, for me, I would have to either change my display settings to zoom out, or I'd have to click these one at a time to then be able to pass in data to them. Either way, kind of time consuming. So I do want to show you though that this does work. So let's pick one of these, and I think what we can do is let's do the PV. So, or you know what? No, let's do the name. I think that'll be easiest. So I'm going to come over here. Oh, nice. There it is. Sync params. Okay. Now I do want to show this working. So we will only do one parameter to prove the point, and that is, let's do the name. So if I come over here, I can see, okay, we have a parameter for name tag path. So I'm just going to go to my UDT instance, going to copy the path, and then I'm going to paste that in. Click OK. And now whatever this short name is on my instance, if we want to call it the oxygen valve, we will see that in our view. So you guys get the point. I won't torture you. We won't do all of these, but you kind of get the gist. This is how you traditionally go about building out views. Now, the last thing that we traditionally need on a SCADA screen, especially if we're trying to make it look like a PNID, is the pipes. So Ignition has something called the pipe tool. It's up here at the top, and basically you just point and click. So I can click here, and then kind of drag it, click here, and I can drag it over. It makes these sweet little 90-degree corners. It can do T's and things. It's pretty nifty, right? That is, though, until you're designing and then your boss comes to you and is like, oh, by the way, I want to add a navigation pane over here on the left. And I also want an alarm banner thing. It's basically going to take up a lot of real estate over here on the right. So can you just like scale this all down? And the problem with the pipe tool is it's not exactly an SVG element. So I can't just like select it all and then like easily drag and resize it. No, if it was the case that I scaled it wrong on my first go, it is going to be kind of a manual ordeal to come in here and move these points around to adjust my pipes. But it can be done. All right, so to recap, it's been a number of minutes, and so far all we've done is instantiate one UDT instance, draw a few pipes, and map maybe like 5% of our view parameters. I don't know about you, but I did not find that work particularly captivating. In fact, I found it downright boring, and more importantly, I found it to be very error-prone. My strength as a human is not manually copying and pasting in tag paths. Rather, that is a fantastic use case for AI. So let's look back at what our little tool was up to. Basically, so what we did with our tool is, like I said, we trained it a vision system on the symbols and stuff on a PNID, like, hey, that's what a pump is. Hey, that's what an AI block is. That's what an AO block is. And we said, go find all those symbols. Then we also said, okay, go find the pipes, which connect symbols together, and then help us instantiate that in an Ignition project. So if completed, so we can click this button, and if we're lucky, we have something here, right? So if we double click all these things, now we actually have all of our symbols basically instantiated. Now, of course, I want to be crystal clear. Is this production grade? No, right? For whatever reason, my little AI overlapped that pipe. Oh well, that's easy enough for a human to come in and clean up. But what I'm trying to showcase is we just saved an enormous amount of time on that tedious work we just spent doing together. The other thing that this tool does is it actually gives a shot at guessing, okay, what should the UNS name be for all of this stuff, right? Now, again, do I think that the AI came up with something that you actually want to use? No, of course not. But I would argue it's probably just as good to let AI come up with it as some random SCADA engineer. My point being, when it comes to designing a UNS, and when it comes to actually modeling your data, that should be something that actually a whole group of people is involved in. And it's hard to do, but hopefully if we can use this tool to save time on the instantiation, we can now spend more time in the design and making sure, okay, let's make UDTs that actually really serve everyone and works for everybody in the business. And let's make sure that the names we come up with have really good data governance and will scale across multiple sites. And I can show you too that if we expand this out, it also made, of course, all the UDT instances for everything. Oh, and I guess the other thing I wanted to show was we did meet our SESME requirement in that for ProveIt, they said we could use an existing SM profile, or we could go ahead and say, we're going to make our own data structure and host it external to the broker. So inside every single UDT, if we come into device core, we have a tag here called profile description. If I double click this, and anybody, by the way, can do this. If you go to that URL, it brings you to a public Git repo, and it's basically, hey, this is the JSON structure of our UDT. Now, One thing that's a little tricky with MQTT is that you have the option to turn retain messages to true or false, which basically means when you connect to the broker for the first time, if retain is false, you won't see a message until it gets published, right? Now, I don't love the idea of coming to a namespace and not really knowing what am I going to expect to show up in here. Do I just have to sit and wait some amount of time for things to get published and then say that's probably it? I don't love that. So what we did for this specific use case for PTT, we actually added an extra topic, underscore profile. So let me expand this out. And this one we put retain to true. And it's basically a summary of what you can expect to find in this area. So I don't know if you guys can see that. It's basically saying, hey, you're going to have 5 valves who have this profile. You'll have this number of DIs, et cetera, et cetera. And again, if you want to know what that is, you can just follow the URL to the public repo to see the structure. And I do want to be crystal clear. This isn't magic, right? We did have to take a solid day to set up this tool to work. You know, we did have to basically train it on all of those images, and there's a bunch of tuning parameters with that, like what threshold will successfully detect all the valves. If it's too low, you'll get false positives. If it's too high, you don't detect enough. That did have to be done. And there are also a few config files we had to set up that were all JSON. So the good news is it's really easy to have an AI agent help build those config files, but that's something that you'd want a human to look at. And those files basically said, okay, for this symbol, it maps to what view in ignition. Similar deal for this UDT, if it goes to this view, what kind of tags kind of go into it, right? But the cool thing is once you do that setup work once, it then becomes really fast to just do basic instantiation. Now, I don't know about you, but I think that's some pretty cool technology. For PTT, we just showed how we can drastically cut down on instantiation time for building a SCADA system. That way humans can spend more time on actual design. Like, okay, what do we want the views to actually look like? What's the user experience? What is the right UDT structure, right? And that's because this tool set, it'll work with any UDT structure in the backend. However, let's say that Skellig did bid on PTT's SCADA project and we didn't tell them about the tool. So we just said, all right, we know that you have budget to do this without AI and stuff. So we're just going to come in at 20% less than our competitors. And we deliver a SCADA system a little bit cheaper. Would that actually fix their organization? I'm going to say no. Because what do you think happens after the perfect SCADA deployment? For a company like PTT, I bet not much else changes. Because what I have seen is a lot of life science sites have very siloed departments. There's a very good chance that PTT wouldn't just magically start solving their MES problems on a common infrastructure. And that's because they are organizationally fragmented and siloed, much like their data was. Which brings me to the second problem, which is the human one. Enterprise C is so far behind because they aren't agile and they don't quickly adopt new technologies. Obviously, what they really need is a better digital strategy and way of operating. But the problem is changing human behavior, it's not glamorous. Honestly, it's not something that I can do for you in a 30-minute demo. Because the truth is, the only way to fix human problems is by talking to humans. The good news is the answers are inside your organization. From my experience, usually there are people who know exactly what they need in order to fix their area, but they might not have the access or the political power to make change happen, or just in general, their organization isn't set up to enable people to solve their own problems. So what you really need to do is start with an assessment of your organization. And so What I would recommend for PTT is, hey, you need to have a series of workshops where you map out your existing business objectives, operational pain points, digital landscape, figure out what is your corporate digital strategy. And doing that requires talking to stakeholders from all parts of the organization. You know, we're talking from like your operators, MSAT, manufacturing, IT, and definitely don't skip QA. Because let me tell you, in life sciences, if you don't understand how to properly use risk assessments, trust me, you're just dead in the water. And only after you talk to everybody can you assess all your problems and say, okay, this is what we need to change from a cultural standpoint, and this is what we also need to change from a technology standpoint. And then you solve that, prove value, and iterate from there. And from what I have seen, most companies skip this step entirely. And I get it. It is so much easier to say, let's just get funding for a project. And that's why, for the first time ever, Skellig is announcing a new offering at ProveIt. And we call it Phase 1. It's $40K for 4 weeks, 160 human hours. And it includes the 2 phases that I just described, the assessment and then the roadmap. Now, here's the thing. The AI tool that I just showed you, we bundle it together with Phase 1. So if you come to Skellig for a SCADA project, the AI-generated boilerplate, it's free. $0. We're not going to charge you. You only pay the human billable hours to bring it up to production grade. But here's the catch. You only get access to it if you also buy Phase 1. Now let me explain why we do it that way. First, if you just don't understand AI, you might incorrectly think it can replace people. And I want to be crystal clear, that will only lead to disaster. Agentic AI, it's very powerful, but it has limitations. And you need to know where the balance is. And I want to make sure that whoever I work with understands the role of AI in their company, which is it is an enabler. You never use it to replace people. Rather, you use AI to enable them to solve problems they previously couldn't. You enable them to deliver levels of quality they previously couldn't. Second, if you just use AI and you don't fix anything else, if you don't address the root cause of why you're in the place you're in, all that's going to happen is you're going to make bad decisions faster. Like instantiating bad UDTs, ones that don't tie into a broader digital strategy, that doesn't help. Like, look at PTT. Let's pretend, Skellig showed up and we did give them a SCADA project. That's cool. What are the odds they're suddenly going to fix their paper batch records and all of their siloed departments and all their strategy problems? I'm going to say low because they didn't take the time first to address the human element. So our hope is that if you have a SCADA budget, now with AI, we can cut down on some of those painful billable hours to instead increase the quality delivered and repurpose some of that old budget into solving problems you previously didn't have time to solve. And if that's something you're interested in, I recommend you go check out skelligexpo.com. And this here is skelligexpo.com. So at the very top is a button. Basically, if you do want Phase 1, you just have to click that button and we send a formal quote straight to your email with instructions, hey, this is how you send a PO. The idea being, if you don't want to talk to a salesperson, you don't need to. Just push a button. But if it is the case you want to talk to a salesperson, we got a button for that too. Now, again, the thing about Phase 1 is it is those 2 steps. It's that assessment and then that like roadmap planning, like, hey, this is the first use case you should do. After Phase 1, you have the option, if you want, to hire us to actually execute on that. And we work then in 2-month intervals in an agile fashion. So basically every 2 months, you get to decide, hey, are you delivering value? Now let's keep this going. Or if for whatever reason we're not, you can walk away, no problem, no strings attached. And the reason we structure it this way is because digital transformation, it's not a single project. It's not something with an end date. Typically, it can take 1 to 2 years to actually revolutionize a company. And I think it's risky and unfair to say to somebody, hey, hire me for 2 years and trust me, it'll work out great. No, instead, we do Agile so it's low risk for you and it forces us to stay honest and keep delivering value. Now, truthfully, I don't even care if you hire Skellig to do this. There are tons of brilliant engineers, especially in the 4.0 community, who could help. But the reason I wanted to intentionally make this a product is I know, psychologically speaking, it's much easier to get a company to start this journey if it has a fixed cost and scope. So we're saying 40K, 4 weeks, and then just 2 months at a time. And I guess the last thing I want to point out, if in general you just want to talk to somebody at Skellig, you can come to this What We Do page. And again, all of our leadership is here, just a button away. And yeah, that kind of concludes our session. Woohoo! End. All right. I guess one other thing I do want to shout out to. So something we did at ProveIt this year was I was worried people were thinking, oh, you just like built the screens in advance and loaded them. I wanted to show, no, this really is auto-generating. So if you came up to our booth, you could actually draw your own picture and see it get made in Ignition. And so I do want to shout out our winner because basically all the attendees got to do that. And here in the namespace, you can actually see like these are the people who participated. Their stuff did get published out automatically. And we had a page where people could vote on the best ones. And our winner this year was Tracy Hart. So Tracy actually won it. And what was amazing is the Raspberry Pi, she said, actually went with her 13-year-old son because he's going to use it in his engineering class. So that was like the best possible outcome of it. So thank you so much, Tracy, for sharing that. That was incredible. Yeah, so that wraps it up. Thanks everybody for watching, and I hope to see you at ProveIt next year.